Uh, Perfect timing. Um, Welcome to the February meeting of the RASC-Kingston Centre. And my name is Malcolm Park. I'm the president of the Kingston Centre. Um, at the outset, we usually have David say a few words at the beginning of all of our meetings. And I'm happy to see that he was able to join us this evening. So, David, if you're ready, I will give you the floor.
Thank you, Malcolm. It is wonderful to be here attending perhaps the most consequential astronomy club in the world. It was founded by Dr. A. Vibert Douglas, and then she went to McGill and then retired back in Kingston, where I get to know her, and got to know her, and we got to be very good friends. Tomorrow I will be leaving for the Lowell Observatory to be part of a celebration called Pluto Planet Day. And apparently that observatory feels very strongly that Pluto should remain a major planet in our solar system. And I certainly share that feeling, but not for any scientific reasons. I share it because I knew Clyde. We were good friends, and I wrote his biography, and I know how upset he was at the end of his life with the possibility that he was going to lose his signature discovery. He was also upset when he was let go from Lowell Observatory. And during his last years of life, we talked over and over about that. And for my quotation tonight, I would like to quote from my own biography of Clyde. The telescope Tombaugh was finally about to leave stayed at Lowell Observatory. Its long career not nearly over. Years later, director Arthur Hoag claimed that with its many projects, the 13-inch had become one of the world's most productive telescopes. If it had consciousness, it might have wondered what would happen without the man it had shared a life with, a man who had never quite given up searching one more pair of plates for hidden treasure, a man who called himself a traveler, going over the next hill with an eternal hope. Thank you, Malcolm, for letting me quote this, and back to you.
Thank you very much.
Thank you.
So the opening slide for this evening's meeting is it has a picture of the Vela supernova remnant, and I just wanted to give you a sense of how big this thing is. This image was taken in Chile with a DSLR lens, a Rokinon 135, and this is a 4-panel mosaic with that Rokinon 135. And to look at it, you see color and you see structure, but there's no real indication of scale. You see often an image that's taken, an astrophoto, and this is partly because we have astrophotography workshops in the center these days. So this image is an example of the kind of thing that anyone can do with the simplest equipment. And to demonstrate exactly the scale, you need to actually do an overlay of with the annotation. And so now you can see, hopefully, maybe, but I'll read it for you if not, that on the left, that would be minus 39 degrees, and on the right, that's minus 51 degrees. So the width approximately of this is 12 degrees. And if the full moon is a half a degree, then putting it more in context, that's approximately 20 to 24 full moons in width. This structure is enormous. It was a type 2 supernova thousands of years ago, and it's 800 light years away, and really it's just huge and probably the size of even the Large Magellanic Cloud. So Now, on to the meeting agenda. Um, First off, welcome to all of our guests this evening. It's great to see you all. Um, there will be an announcement followed by our feature presentation, Alan Dyer, and his presentation on cosmic connections, how the moon, stars made Earth and life possible. After that, there will be time for Q&A, and then there will be a 5-minute intermission. We'll have What's Up in the Sky with Rick Wagner, and John Hurley will give us a National Council meeting report, and our member Bruce Elliott has a report for us on what's happening with our preparations for the Science Fair and Science Rendezvous. I need to find a document. Okay. So the announcement that I want to make is that the Sea Star that we've been talking about getting for the center has arrived. We are in possession of our first Sea Star. We have the S50 model, and the purpose of this is to be used in outreach and in the equipment loan program. We also intend to bring this to Queen's Open House and Science Rendezvous and other events. It has a 50-millimeter aperture and is 250-millimeter focal length. Lots of people have been playing with these and posting photos, and soon our members will be able to borrow this from the equipment loan program. So now I'd like to introduce our feature speaker. There he is, Alan Dyer. I gotta say, one of the decisions the Kingston Centre made with respect to winter meetings post-COVID was that January and February would be Zoom only. And this was mainly due to the risk and uncertainty of stormy weather on meeting night. We do have members that drive a fair distance on meeting night, and looking at the conditions even now, it is a good thing we are on Zoom. Another bonus of Zoom meetings is that we get to cast our net far and wide in search of presenters, people that we wouldn't usually be able to invite to Kingston. Another bonus is that I get to do the inviting in this instance. And so tonight, live from Strathmore, Alberta, we have Alan Dyer with us. I have been a fan of Alan's for many years. His writings and books have been a great source of education and inspiration. Going back in time to my second solar eclipse trip, which was to Tahiti in 2010, I think, which Alan was on. We have sort of kept in touch over the years since that time. On that trip to Tahiti, it was noted that one less nagging might be the reason that the trip went the way it did as far as the eclipse is concerned. But then later, much later, that theory was disproved. We did invite Alan to present at Starfest in around 2011, which was a real treat, as the Saskatchewan Summer Star Party usually is where you will find Alan in August around new moon. Alan is a top astrophotographer with APOD space weather credits, member of TWAN, TWAN. He is an author, product reviewer, and blogger. He has an excellent website that you should check out at amazingsky.com. You can find all of his works. His photos always tell a story about the amazing sky or what's happening in the world at night. And he takes the best selfies, I would say. So please welcome Alan as he takes us on a visual tour of the wonders of the sky, with an emphasis on how what's up there affects what's down here. And Alan, please give that share a try.
Thank you very much, Malcolm. It's a great pleasure. Let's see. I just got to share here and get underway. The Zoom controls always hide. There we are.
Yeah, it figures.
There we go. All right, here do we see the title slide?
Yes, is it a field of lupins?
Yes, it is, with the the title of the talk. All right.
Yep,
You're
got it.
seeing my screen. Okay, great. All right. Well, this is a talk. Actually, I gave a version of this talk just a couple of weeks ago in the local community in the local art gallery here in Strathmore. But it's a version of the last talk I give during the Aurora tour sessions that I conduct or help conduct in Churchill. I'm going up there next week to do my last sessions up in Churchill, and I do sessions in Norway. And the final talk in the week-long set of talks at those Aurora chasing tour groups is something like this, to kind of put it in perspective as to how what's up there we see in the sky affects us down here. Obviously, we decided to chase auroras, so it has had an effect on us. And I'm going to finish off tonight with that connection back to the Northern Lights as well. But I'm going to talk a little bit about how the moon and the stars really affect us, and not in any kind of astrology, oogly boogly way, in science, in a way science has something to say about. But first of all, a coming attraction. And Richard may be talking about this later on in terms of what's coming up. But a month from tonight, because tonight's full moon. So one lunation from now, we have the next full moon. And the moon will undergo a total eclipse at that time. So it's the night of March 13th after midnight into the early morning hours of the 14th. So don't go out on the night of the 14th hoping to see it. You'll have missed it. But I mention this because obviously it will affect us in a way that we're going to go out and try to observe it in the middle of the cold night or whatever it is. And it's a beautiful sight to see, a total eclipse of the moon, much more frequent chances to see one than a total eclipse of the sun, although we had one just a few months ago, a year ago or so. So I just want to point that out. And this is a little animation of the moon moving through the Earth's shadow, the umbral shadow, and it spends about an hour and 10 minutes or something. So it's a long, graceful affair. It's beautiful to look at, beautiful to photograph. Doesn't have the excitement and the stress of a total solar eclipse, but that's just fine. And you can get great views, naked eye, binoculars, or whatever. So do avail yourself of the chance to see the total eclipse of the moon coming up 1 month from now. And when you do, think about the moon, because the moon is, oops, now suddenly I'm not advancing the slide. Ah, dear. Suddenly I'm frozen up.
We
There
do
we
hear
go.
you.
There
Okay.
we go. All right. All right. Because the first part deals with the moon. We take it for granted, except perhaps on a special event like a lunar eclipse, something like that. We take it for granted. Sometimes we even curse it, lights up our sky and hurts our deep sky photography. But it's a very special world, and it's kind of our odd neighbor. We take it for granted, but we are in fact a double planet. The moon is quite a size compared to its parent planet. It's the planet that it orbits. So it's a quarter of the size of the Earth, and very different from the Earth, as you can see from this NASA space probe animation as it was heading off to parts unknown in the solar system. The Earth, this beautiful blue living world, and the moon, the dark desolate world. But we do take it for granted. It's our double planet. This is from a spacecraft orbiting the moon and the Earth in the distance, and then this is the actual scale of that, with the Earth and the moon and the distance between them to scale. So it's the nearest world to us, but it's as far as people have been into space, into deep space, and we hope people will be heading back there soon, perhaps as well, including a Canadian in a year or so. The moon is one of these interterrestrial worlds. Not a planet, of course, it orbits the Earth, it's the moon. But it's one of these 5 solid worlds in the inner solar system, along with Venus and Mercury and Mars, the terrestrial planets. And the moon kind of ranks up with them. It's a little smaller than Mercury, but it's a substantial world. Somehow my advance keeps stalling on the my computer keeps locking up and unable to advance the slides. Oh, now it goes. All right, so this could be an issue tonight. Well, the moon is quite large compared to its parent planet. Now, there are larger moons in the solar system. For three of the moons of Jupiter and Titan around Saturn is bigger. But compared to the size of the planet it orbits, the moon is quite large, really larger than any other now official planet. Only Pluto and Charon are kind of similarly matched in size in terms of a moon as a significant size of its parent planet. Yeah, sorry, my presentation keeps locking up and unable to advance.
Well, we're happy to wait.
Yeah, and I can't even get at my oh, all right. Now I've exited the program. All right. And of course, the moon is the only place the astronauts have been, Apollo 17 being the last time in December 1972. And it's the hundreds of kilograms of rocks that they brought back, which gave the evidence for this theory of how the moon formed. It was really a bit of a mystery. Still a lot of unknowns about how the moon formed. How did we get this big, large moon? It's not a consequence of the natural formation of the Earth the way some of the other moons formed. It's around the other planets. It's totally a chance event. It formed from this catastrophic collision early on in the age of the Earth, before the Earth really had formed fully. When a Mars-sized world came along, this is a fantastic animation. At a glancing blow, it had to hit at just the right angle to blow off what they now think, according to this model, two large objects. The smaller of the two went on to become the moon. The big remnant of that colliding planet went into the Earth and became part of the Earth. And there's even some evidence for detecting that irregularities in the outer core of the Earth may be due to that object inside our planet now. And so the gravitational effects of that launched this other smaller object out into quite a close orbit around the Earth, but it's been receding ever since to form our moon. A totally chance event. Had that collision not occurred, we wouldn't have had the moon. Had it occurred in some other fashion, we wouldn't have had the moon that we had, perhaps, in some other angle. And so it's totally surprising that we have the moon that it does. It's the result of a rare and unlikely chance event, and yet it's how we got our magnetic field, perhaps. Without that collision, we might not have the magnetic field that we do around the Earth. It's possible that that collision really changed the interior of the Earth to set up that fast rotation and circulation that creates the magnetic dynamo, the dynamo inside the Earth that generates that magnetic field. We might not have it. Venus doesn't, rotates very slowly, same size as the Earth, doesn't have a magnetic field, rotates very slowly. Mars rotates more quickly, but it lacks a magnetic field either. And so the first set of cosmic connections are from the moon. Is that big splat theory perhaps created the Earth's rapid rotation, which contributed to the core circulation inside the Earth, which generates the magnetic dynamo, which creates the magnetic field, which shields our atmosphere from erosion by that solar wind. And I'll get to that at the end. But without magnetic field, the sun's solar wind would be impinging directly on our atmosphere and might blow away our atmosphere after time, as has happened on Mars. So that magnetic field is very important for protecting the Earth and making the Earth livable or habitable, perhaps. And that interior circulation creates plate tectonics, the motion of the crustal plates, the continental plates, which generates earthquakes and volcanoes. But it also contributes to what's called the carbon cycle, where carbon dioxide gets sucked back into the Earth and prevented from getting out into the atmosphere in great abundance, as has happened with Venus. So it prevents us from becoming a super hot Venus. The fact that we circulate the carbon in our atmosphere, and the plate tectonics is an essential part of that carbon cycle for making that happen. And yeah, sorry, it just locks up again, and I can't do anything until somehow. Come on. And also, the moon gravity stabilizes the tilt of the Earth, so it kind of makes our seasons a little more regular, unlike Mars, again, which goes through a lot of extremes. So life might be possible because of the moon's presence. So don't take the moon for granted. It perhaps has made the Earth habitable. And there's no reason why we should have a big moon like that, but we do because of a chance event. Now, when you look at the moon, and this was, what, a month ago, when the moon passed in front of Mars. So here we have the two terrestrial worlds in the same field of view here. When you look at the moon, you see all these dark areas, the Mare areas on the moon, and Tycho here as well. You see the effects of the impacts. And it's those impacts that also have a tremendous effect, have had a tremendous effect on the Earth. And we see them recorded on the moon, which is a great reason for going to the moon, to get more evidence about the history of the Earth and the moon. So the comet and asteroid impacts, they also bring water, life, and also death to the Earth as well. So those impacts of objects like icy comets, like these that have been visited by several spacecraft over the last 20 years or so. So we have much better evidence now, and even samples back from some comets to know what they're like. And also the more rocky asteroids, and we definitely have samples from these now. In fact, just last year, no, September 23, the OSIRIS-REx probe, before earlier than that, it touched down on this asteroid Bennu and then brought back samples to Earth from that rocky asteroid. So these are the typical kinds of objects that can impact the Earth. And it was just a couple of weeks ago where the first science results were released from the analysis of those samples to reveal that in those samples from this asteroid, tiny asteroid, there are amino acids, many of the amino acids that go into the composition and the makeup of life. So the basic, not just the basic elements, but more complex molecules are in these comets and asteroids. And so the impacts in the early solar system, as we saw the moon, can have disastrous consequences, but they can also bring the stuff of life to the Earth as well, the right ingredients. There was a lot of impacts in the early solar system, and when there was a lot more stuff flying around, and those comets and asteroids, and there's a discussion about what role the comets had versus the asteroids, brought the ingredients for life perhaps to the Earth as well. And these are some other molecules that were detected in the samples from the Bennu asteroid and just announced a couple of weeks ago. And including water itself, perhaps, as well. And I know David has spoken about this eloquently in his comet talks as well, where comets are icy, but also there's a lot of water in these asteroids. And it's thought that maybe the asteroids might have had a great contribution to the bringing water to the Earth. There's debate about this. How much water was in the Earth already? How much had to come from outer space? But certainly the asteroids and impacts of asteroids and comets could have had a big role to play in bringing the water to the Earth that we have now, which is absolutely essential, of course, to life on the Earth. But these impacts also had, created mass destruction on the Earth as well. And throughout the history of the Earth, certainly in the last 500 million years or so, when there's been advanced life on Earth on the surface, there's been several mass extinctions. And the last one, the KPG extinction 66 million years ago, is definitely linked to a big impact. But there's others. The evidence is not so clear as to whether they were caused by impacts or not, or some other types of geologic events or continental drift or whatever. But nevertheless, we certainly have some evidence that impacts have certainly wiped out a large portion of the life on Earth. They brought water and the ingredients and the organics necessary for life on Earth, but they may have also wiped out much of life on Earth. They also certainly redirected the course of evolution. If the dinosaurs hadn't gone extinct, we might not be here. And the mammals that had the opportunity to take over, we might not be here. Because if it weren't for that massive impact 66 million years ago, what courses would evolution have taken had these impacts not occurred throughout the last hundreds of millions, if not billions of years of Earth's history? So once again, comets and asteroids, once considered not worthy of study decades ago, are now absolutely critical to our understanding of the origin of the Earth and life on Earth. Now let's move out a little bit more into space, the lives of the stars. They are stellar element factories. So moving out and talking about stars themselves now. This is an image I took last July, and I'm killing time again because the computer's locked up again, in Yoho National Park in BC, showing the stars over a waterfall, the largest, highest waterfall in Canada, I think, or one of them, Takaka Falls. All right, I keep hitting a key, hoping it will respond, and eventually it does. No, come on. There we go. Well, stars, the birth of stars. Stars are born in these nebulas. The Orion Nebula, the most famous in our sky right now, right now, exactly. Orion the Hunter, where new stars are forming out of these clouds of gas and dust. Our solar system formed out of something like this. A little later in the stage of evolution, you get something like the Pleiades star cluster, formed out of a cloud like that. So this is a fairly newly formed group of stars, only 100 million years ago or so, moving through dust that's elsewhere in our arm of the galaxy here. Um, and then those stars are like our sun. Our sun, typical star, big ball of plasma called gas, but it's really plasma, fourth state of matter, with this very hot core, which is undergoing thermonuclear fusion. That's how the sun is, and all main sequence stars, normal stars, are generating their heat and light, is they're fusing atoms together deep inside the core, where the temperature and the pressure is tremendous, and that energy gets out to us on the surface. But inside the sun and typical stars, the energy is being produced by the sun fusing four hydrogen atoms into one helium atom. And one helium atom weighs a little less than four hydrogen atoms. So the excess matter is turned into energy, a little bit of energy for each one of those reactions, but there's tons of that matter being turned into helium every second. And so there's a tremendous amount of energy being produced by the sun. But also, as the sun makes the heavier elements, hydrogen into helium, but also helium can then be fused into heavier elements up the periodic table that I'll show you in a minute, like carbon, absolutely essential to life. And then carbon can be fused together into nitrogen and oxygen. Carbon, nitrogen, oxygen, and hydrogen, absolutely key elements to life, all life. The elements out of which those complex molecules found in the asteroid are made. And so stars like the sun are constantly making elements, heavier elements, but we can't make use of them. They're of no good to us unless that star blows them off out into space as part of its end of life process. And we have a nebula. Here's the shot I took a couple of weeks ago from the backyard here of another nebula in Orion down the bottom. But the one in the center is in Gemini, and that's the remains of a supernova, similar to the Vela supernova remnant Malcolm was showing earlier on, a much closer one. This is farther away, probably much older. But you can tell, as with Vela, something has blown apart. That's another remains of a supernova star thousands of years ago that exploded. So a star produces those heavy elements, has to blow them off into space in order to be made use of by other stars in as part of their formation process. And in our sky right now, we have the red giant Betelgeuse. This was a shot of the last total solar eclipse, I think, a couple of years ago from the backyard. So the moon, the eclipse of the moon is over on the right, but there's the red giant star Betelgeuse. That's probably the best candidate we have for a naked eye star that is a candidate to blow up as a supernova. Uh, Thousands of years from now, likely tens of thousands, but nevertheless, it's a fairly large, unstable star. It will explode as a supernova at some time, and then off it goes, as has happened many times throughout the history of the galaxy, including nearby, as Malcolm showed us, where the star blows itself apart and just so much of its material gets blown into space to now seed the galaxy with those heavy elements. Plus, more elements are made in that actual explosion by the energy of that explosion. This is animation, but ends up fairly realistically depicting the Crab Nebula in the constellation of Taurus. That's my little puny picture of the Crab Nebula from the backyard here. But again, something that's exploded, and it looks like that. And then the computer's locked up again, so we wait again. And so there's lots of these supernovas around the sky, supernova remnants around the sky, and then our sun is not a kind of star that's going to blow up as a supernova. It's going to end its life in a little more sedate fashion, and I'll get to a slide of that in just a moment as soon as I can. Oh, I do love Zoom. Just come on. Yeah, I can't even escape the program I do apologize.
No worries, Alan, no worries.
Yeah. Now this one's taking a long time here. Come on.
One of the advantages of the slide projector hanging up like this is that it tends to do it on the pictures you took, which give us all a
Well, it's
chance to really
not really
relish
intentional.
in these wonderful photographs. I just love being able to watch them for a long time.
Sorry, I can't even. Oh, okay. It just. I still can't. I can't. Well, I'm just locked up. I can't advance. I can't get out of the program. I can't see
Alan,
the
while we're
Earth.
looking at your picture, a quick question, if I may.
Yeah.
Do you still, when you're taking DSLR pictures, do you still use the inbuilt dark frame auto noise subtraction instead of using a dark frame separately?
No, no, because I don't shoot DSLRs anymore. I shoot with mirrorless cameras entirely for the last 5 years or
Oh,
whatever,
well,
and
it
they
would be
don't
this.
have that.
No, okay.
Or they do have that. They don't have the buffer that the old DSLR Canon DSLRs had, and so I don't. No, I don't even take dark frames. I just do dithering and just use the stacking to eliminate thermal noise.
Okay.
So
But you know what I'm talking about. You at
yeah,
one
that's
point you
all I do.
talked about
Sorry.
the halos of the stars that would show up, and if you did it in camera, the halos would not show up.
Hey,
No, sorry. I,
hey,
Anyways, okay,
Malcolm,
thank you.
yeah,
Malcolm,
yeah. How
Kevin here.
how
Can you
about
stop
how about
Alan's
you stop my
screen sharing?
sharing? Yeah,
Yeah,
stop my sharing.
Malcolm can do that. Yes, and you may get
Yeah, because
control
I
back
can't.
that way.
Completely locked up. Okay. Now start my sharing again if you can.
You
Nope.
should be able to.
Yep.
Is this a bandwidth issue, or is like
I
maybe
don't know.
sometimes if you turn your
How's
video
that?
off while you're presenting, you might increase the
How's that? Are
bandwidth.
you seeing the screen now?
Yes.
All right. We just advanced. This time I shared the I don't know, application window, not the keynote. I don't know. It's just let's see if we can get through it. Sorry.
No,
All
no,
right.
it's all fine. No problem.
The other kind of nebula that forms as a result of the end of a star's life is, and something that's more typical of what the sun's going to do, is these planetary nebulas. The Helix Nebula is one of the closest and biggest to us. This is a shot I took in Arizona last October. And so now the sun doesn't blow up catastrophically. It just slowly over thousands of years blows up more and more of its atmosphere. But nevertheless, the end result is heavier elements getting blown into space. And so there's to make use of the elements that stars make, they have to get out into space through these end of life events, planetary nebulas, catastrophic events like supernovas or whatever, so that they can be seeded into to form the next generation of stars. Our sun is something like certainly second, if not third generation or whatever. But one of the final outcomes of a supernova, the star doesn't blow itself apart entirely. In some cases, it forms the remnant core, collapses down to form what's called a neutron star. Very small object, the size of the city, as you saw, made out of just solid neutrons, incredibly dense and very radioactive in the sense that it's sending out beams of radio pulses as a pulsar. Well, one neutron star is weird enough, and the first one I think to be discovered is the one inside the Crab Nebula, and as a spinning radio beacon, and it's a neutron star. One neutron star is bizarre enough, but you can have two of them orbiting each other. How did they form? Two supernovas had to go off next to each other, and they can over time lose their orbits shrink, and they collide and collapse and form an even more dramatic event than a supernova, even more energetic. And this was first observed by one of these gravitational wave observatories in 2017. And that became the answer for how we got the elements heavier than iron. There was a lot of arm waving years ago that they were made inside supernovas, but the theories never quite worked out. And it took the realization that you get an event like this, a really dramatic event like this, colliding neutron stars, to make something even more powerful than a supernova to create the really heavy elements. Gold, platinum, and uranium came from colliding neutron stars. Extremely rare events. But if you've got any gold, you can thank an event like this for having produced that gold in your jewelry. So here's the modern periodic table of the elements here, the origin of the elements, which you all are familiar with in science class or whatever. And now it's indicated with where the elements came from. And only the simplest elements, hydrogen and helium, were made in the Big Bang, the origin of the universe, and a little bit of lithium. Everything else, bar for a couple elements made in cosmic rays, everything else is made inside stars and then blown into space as part of the end of life of that star in some cases. A small star like the sun or a big star like a supernova. And all the heavy elements down there, and certainly all the elements heavier than carbon, are made inside stars. And all the really heavy elements down at the bottom of the periodic table are made inside colliding neutron stars. And so that's fairly new information in the last 10 years or something like that, that realization. That, as Carl Sagan said, we truly are stardust. And stars died so we could live in that sense. And that's the real connection with the stars. That I think is just amazing. And I say Carl Sagan spoke of it eloquently 40 odd years ago. But we know more about it now. It's even more true. Elements heavier than helium were made inside stars as part of their normal lives or as part of the actual catastrophic star death event. And elements heavier than iron were made by colliding neutron stars. Without those elements, many of those radioactive elements, Earth would not have a molten core. It's that heat from the radioactivity that keeps the core molten. And we wouldn't have the plate tectonics. We wouldn't have the protective magnetic field, and we wouldn't have auroras. So I'm going to finish off just by zooming back to the solar system and our sun, which is, of course, the most important cosmic connection. Is the sun is our source of light and heat, warms the earth, makes life on earth possible. And all sources of energy, in a way, can be traced back to the sun directly or indirectly, or from the stars, in the case of nuclear fusion, nuclear energy, rather, where we're working with the heavy elements made inside other stars. But the sun also sends us matter, electrons and protons, streaming into a space that also affect the Earth. And the sun's been very active in the last year or so, as we know, with a huge number of sunspots in the sun. And we saw some of the effect of the solar wind for ourselves on April 8th last year, right where you are. And I drove all the way to Quebec to see this view of the total eclipse. And if that's your only view, great. But gosh, you want to get to see another one. But that's the only time you can see the effect of the solar wind, the sun's corona, blowing off into space. But spacecraft, of course, can see these coronal holes and coronal mass ejections and the sun sending us stuff our way, which interacts with the Earth's magnetic field. And so that stuff comes streaming in from the sun, and that Earth's magnetic field protects us like deflector shields from the full onslaught of these solar storms. But some of that energetic particles get around to the night side of the Earth. They interact with the particles already there. They squish the magnetic field lines, and they get injected, and those particles get injected with much more energy and are shot back to the night side of the Earth, following the magnetic field lines to form an oval of light around the north and the south geomagnetic poles. And that's a view of the actual auroral oval, taken over time, not a snapshot in time, but taken over several hours, on May 10th last year, the auroral oval in the northern hemisphere. And that was a huge storm. A month after the solar eclipse, we got another amazing sky event. This was from my backyard. I gave a talk in Strathmore that night and said to the audience, well, I'm rushing home because we could get a great aurora. And this is what happened. I mean, even in the cloud, we were seeing vivid greens and pinks. And if you had clear skies that night, most people in North America were seeing a fantastic display of northern lights. And down in the southern hemisphere, the southern lights as well. And whoa, there was a sudden substorm came rushing in there. And so, what a great year last year was. And so far, it's been pretty quiet, but we're hoping for more displays. But the point to end off here is that we wouldn't see auroras like that or at all unless massive stars exploded and blew their material out to see the galaxy with the radioactive elements needed to keep the Earth's core molten and create our magnetic field. And then we also wouldn't see auroras along this auroral oval, or perhaps at all, if the Earth didn't have this dipolar magnetic field due to the rotating inner core, outer core of the Earth, which perhaps was shaped or even created by the big splat that made the moon. We might not have northern lights the way we do, shaped the way we do, if we didn't have the moon impact, perhaps. And certainly, auroras are green and red typically from oxygen. And oxygen is this reactive gas produced by life. There's geologic ways of doing it, but to maintain it in the atmosphere, life has to be constantly replenishing the oxygen in our atmosphere. If Earth had no life, we wouldn't have that oxygen and we wouldn't have visible auroras as we do. So when you look up at the northern lights, you can thank them as being an indicator of life on Earth. The green glow of the aurora is the result of Earth being a living world and the only planet we know of with life. So we live on this living, dynamic Earth. It's the result of the laws of nature, of course, but it's also the result of the many chance events and cosmic catastrophes, which, if they hadn't happened, Earth would be a very different world than it is today, and perhaps not even habitable today. So it's the result of these many connections between the Earth and the sky that shaped and continue to affect and shape our world. So I'm going to leave you with the words of the great philosophers Calvin and Hobbes here, who, as they stare up in the sky, of course, said, if people sat outside and looked at the stars each night, I bet they live a lot differently. And we as astronomers know that, but I think hopefully now you have a bit more appreciation. So thank you very, very much for your patience tonight.
Absolutely. Alan, that's awesome. Hey, I picked the
And
right picture.
yeah, you did. This was from Grasslands National Park, another great aurora show on Perseid meteor night, August 12th, I think it was. Went out to Grasslands hoping to shoot the meteor shower, and the aurora photobombed at the sky. Fantastic show that night.
Wow.
And again, as Malcolm said, that's how you can get in touch with me at my website at amazingsky.com. So thank
Alan,
you very
there's
much.
one thing I would like to say, and that is that you are freakishly talented. From the very first picture, which is when your program hung up, it allowed me to look at that first picture for a long time. And the more I studied it, the more beauty came out in it. It is a work of art. Your lecture was a work of art. Thank you so much for brightening our lives today.
Thank you, David.
Absolutely.
Thank you. You know, that's a chance to chat with you a bit here. You remember back in the 1980s when I was in Edmonton and at the Edmonton RASC there, and a number of us avid observers would pile into our cars and have a cavalcade down to Arizona for our Mecca visit down to Arizona. And we would visit you and literally camp out in your backyard and have our observathon there in Arizona back in the 1980s. Those were great, and thank you so much. All right. Well, questions, if there's questions at all, and you can
All right.
end
I'm
my
going to
share.
change the view here to, oh, you've got it. Good. Alan, thank you so much. Just on behalf of the Kingston Centre and everybody in attendance, that was a very, very inspiring and wonderful talk. Your images are amazing. I just never, I'm never cease to be amazed that the story you tell with your photos, and it is always obvious. Like, you know, there's no ambiguity. You may not have a mission of said, to make that happen. But this is what I feel every time I look at your photos, is like I understand something more about the universe, or I see something more in context, I think. So on behalf of all of us, thank you very much for the talk.
Oh, you're very welcome, and thank you for your attendance and your patience tonight. I knew something was going to get messed up with
Oh,
Zoom.
it was barely noticeable. You handled it like a pro. I think I'm going to start off with the first question,
All right.
and it's almost more conversational. But when we're growing up, and when we learn about the formation of the solar system, and I'm talking about in the 70s for myself, and we get the idea that everything was a cloud of gas and dust, and then it eventually coalesced into the planets from that, and the sun as well. But over time, perhaps we're told maybe the water came from comets, et cetera, et cetera. But we were also given the impression that the planet was seeded with the elements individually, and that on the surface of the planet, then they formed into these elements of life. And now we're seeing from the discovery on Bennu that these amino acids already exist. That's mind-blowing to me.
Yes, I mean it was many years ago. Canadian or Gerhard Hertzberg was one of the first to pioneer the discovery radio evidence of complex molecules in space. But now with these sample returns, we're now getting direct evidence of not just alcohols and things like that, but very, very complex molecules that are able to form in space. Now, how does that happen? When does that happen? And how much is that essential for bringing stuff to the Earth, and how much is already here? I'll leave that to the scientists to kind of work out the details. But getting this actual evidence from sample returns is so important. And, the Mars samples or whatever would be amazing as well. And then the Europa mission that's going to Europa now won't be bringing back samples. But, all this is part and parcel of the puzzle of how we got here and how the Earth came to be, and what's on the Earth now came to be, and how unique is the Earth. Did the same thing happen on Mars? Did life get started on Mars as well, and then died out? Or maybe it's still there. We don't know.
And that we're constantly taking photos of these comets. And yet they're so much more than just that pretty picture, right?
Yeah, and certain David can remember when comets and asteroids were considered just vermin of the skies, right? Or asteroids were, and comets, well, yeah,
harbingers of doom.
Oh, harbingers of doom. In many ways, they were right. The old superstition in the medieval times, in some respects, but these small objects have played such an important role. And so now they're much more the focus of the space programs of Europe and Japan and NASA as well, with so many space probes going out to the asteroids and comets. Very important to figure out the total picture of how the solar system formed. They played a big role in making the Earth the planet it is. And one way. And so much of that early history is locked up on the moon. So I sure hope they get back to the moon and to get more samples and more, not just scratching the surface, but much more detailed analysis, because that's where a lot of the secrets will lie, I'm sure, is in the moon, on the moon.
We have a question in the chat, and it is from Roger, and he asks, Jupiter also has aurorae. Are they different colors than the greens and reds we see on Earth?
Yeah, there's auroras on other planets, Jupiter, Saturn, even Mars has little patchy bits of aurora. The Maven craft has photographed them. They're little patchy bits because there's not an organized dipolar field on Mars. But they're not green. They may be some red, but it's not oxygen, right? On those planets. It's carbon dioxide or it's hydrogen. So they're glowing in ultraviolet or infrared or purple on Saturn or something like that. So there's auroras. Jupiter's and Saturn's are organized in ovals, but they're not green. We're the only planet with green auroras, and I keep thinking, gosh, if we want to find evidence of life on other planets, these exoplanets, let's build satellites or telescopes that can look for green auroras around distant exoplanets, because
Right.
that would be a key indication. That's not proof, but a very strong indication
Yeah, it would
that world has life.
Yes. And as the exoplanet studies are doing, and they are able to get more information out of the transits about the chemistry of the atmospheres, and then
Yeah.
they start to understand whether there is oxygen in those.
Yes.
If anybody else has a question,
I had a quick question.
Bruce, go ahead.
Can you just say again why the Earth has the green color of the auroras?
The aurora green line and a lot of the reds are from oxygen.
Okay.
Even though our atmosphere is only 21%
Yeah,
oxygen
that's what I was
and
thinking.
78% or whatever nitrogen, nitrogen doesn't contribute the major emission lines, colors. It does produce some blues and reds, pinks in the auroras, and some blues and purples. But nitrogen is not as reactive as oxygen is. And plus, up there, 400 kilometers up, it's oxygen that is more prominent than nitrogen is. Oxygen is the more abundant atom. It's atomic oxygen and then molecular nitrogen. I always get it mixed up as to what's glowing. But it's oxygen because it is the most reactive gas, and it is the most abundant up at very high altitudes. So it's making the green and red. If you see any colors in aurora at all, chances are it's the green. And then the camera picks up the red at the top of the curtains very easily. Your eye doesn't pick it up very much. But there's pinks down at the bottom. Boy, in that time lapse of the May 10th display, it got really like to the eye pink. And that's a lot of nitrogen contributing that. But it takes a very energetic aurora to excite the nitrogen to glow.
Wow, thank you. That's amazing.
Alan, I was in San Pedro on May the 10th. And
right.
I posted this on Facebook. I took a time lapse pointing south, and there's about a 30-minute blurb there of red on the southern horizon.
I remember you posting that. That's incredible. I mean, that's one of the most farthest north for the aurora australis.
Yeah.
But there are historically been records of the auroras being seen down into the tropics and down towards the equator.
Yeah.
It can happen. And I was in Arizona when I took the Helix Nebula shot during an aurora or an astrophotography stint down there for 2 weeks in October. And what happened? The aurora came up, and I saw the red aurora across the north.
Wow.
There was October 10th display, and bright red aurora, and this beautiful star arc across the sky for the camera as well. So I saw a southern version of the northern lights going down as far south as they typically might get. It was interesting to see them from that latitude.
2024 was a good year.
It sure was. And so far, 2025 has been pretty quiet this winter for aurora. But, it was last year at this time, I recall. And then suddenly, boy, things really went crazy.
Anybody else got a question?
Yeah, it's Alan, Calgary. Question for Alan. Why do auroras tend to show up more around the equinoxes, it seems?
Well, I don't quite know the physics of that. It's a well-known phenomena that there's the greater frequency of big aurora displays and solar storms, geomagnetic storms around the equinoxes. Not always. I mean, like the May 10th display, two months after the equinox, and it's just because the Earth, instead of being tilted towards or away from the sun, is more right angles to the interplanetary field, and somehow they connect a little better to give us a greater chance of an interaction between the solar wind coming and the Earth's magnetic field. And you have to have the Earth's magnetic field is pointed north. You have to have the interplanetary magnetic field pointed south for them to connect and to really create a big reconnection event which the little animation showed, to produce the aurora. A bright display of aurora. There's aurora going all the time. I'm going up to Churchill next Friday or week Friday, and if it's clear, there's aurora in Churchill. That's why. And I don't know if anybody quite understands what
No, that's a good answer.
yeah.
Anyone else with a question?
But certainly in 2023, for example, there was a great aurora March right on the equinox, March 21st or 22nd, 2023 was a great aurora that night. And then last year, September had a couple of really good displays in September.
I have a question.
Please go ahead.
Early on in your talk, Alan, you spoke of when the moon formed and that there may be evidence on Earth of the portion that hit our early Earth.
Yep.
Is there a definite demarcation, or is it more scattered?
My understanding of it is that the seismic mapping of the interior of the Earth that's being done.
The parcel is just inside the.
Can anybody else hear him? Is he
No,
muted?
he's muted.
That was my fault. I tried to mute one person and I accidentally muted all. Alan,
Oh.
I boo-booed.
Okay, here we go. Are we back?
You're good now.
Yeah. What was I talking about? The evidence for that impactor, parts of it being inside the Earth, is that the seismic mapping of the Earth's interior has revealed that it's very lumpy and bumpy, that the Earth's magnetic field doesn't come from the actual inner core, but from the outer core, an outer shell. And then above that's the mantle, and then above that, the crust. And that outer core is very lumpy and bumpy. And that's where there may be bits of this proto-planet, which is being called Theia. It may be from that. I don't know how you prove it one way or the other, but that's the thought that stuff, as the animation showed, went inside the Earth and is still there and formed part of the Earth's interior. And the speculation is, or the idea is, that it could have in fact helped create the mechanism, set up the mechanism inside the Earth to make the Earth rotate rapidly enough, and it was rotating much more rapidly early on in its history, to set up that magnetic dynamo to create the magnetic field. Whether that would have happened if the moon impactor had not occurred is debatable. But look at Venus. What's happened to Venus? I mean, it doesn't have a big moon, and it's rotating very, very slowly and has no magnetic field. So it's far from being a twin of the Earth. It couldn't be more unlike the Earth.
Thank you.
Any more questions? Okay. Thanks again, Alan. We really appreciate it. For right now, I think what I'm going to do is just take a short break and give people a chance to get a drink of water or something like that, whatever you need to do. We'll come back and then we'll have the second half of our meeting with Rick Wagner and What's Up in the Sky. So back in a few minutes.
Oh, Steve.
We got to move on.
Yeah.
Okay.
All right.
Rick, are you ready for What's Up in the Sky?
I am.
Okay, let me cancel my share here.
And Kevin here giving everybody a reminder that Rick is on limited bandwidth and there will be audio effects.
Yes.
And once again, we'll try that. Everybody seeing my slide? Yes, I think so.
A slide
All
and
right.
notes.
So, and notes.
That's what it looks like.
Oh. Uh, well, let's see how it looks. So, February 2025, local events. We've got an astronomy on tap coming up on the 27th of February. This is a get together at the mansion downtown Kingston. A little bit of drinking, lots of astronomy, some of the local, a couple of PhD students, I think, and Mike Earl, who does a lot of satellite work, will be talking. The 7th of March, they have their one of their physics department seminars. Renee Hlozek talking about cosmology. There's no detail on the exact subject yet. I think they've changed whoever's booking those talks because there's very few on astronomy, a lot more on particle physics and so forth. However, I will try to keep an eye out. And then 8th of March, the next Queen's Observatory open house. And again, no details on the subject for that one yet. BAA events on the 22nd of February. There's the ARPS Exoplanet Division webinar. This is sort of an all-day thing that unfortunately starts at 10:30 in the morning British time, which means 5:30 in the morning our time. But the keeners will all be up. AAVSO webinars next on the first of Saturday. It's the first Saturday of every month. Deciphering eclipsing binary systems. So that'll be very interesting to people who are into photometry. February hours of darkness. Of course, we're moving closer towards the equinox. During the month of February, we lose a whole half hour of darkness at both ends of the night. So it's rapidly decreasing in duration, and the sun's altitude goes from 31 degrees up to 39 degrees at noon by the end of the month. So we're getting much better for solar observers. Sky events. We had the full moon this morning at 8:53. I was out cross-country skiing on the lake and got to watch it set into the trees while I was out there. Friday, in honor of Valentine's Day, Venus will be at its greatest illuminated extent. So because Venus is coming around the sun and getting closer to us, it's getting larger, but its crescent is also getting thinner. And so this is the point where the sort of total illuminated surface area is at its maximum. And speaking of Venus, look out for during March, we're going to have a really big event with Venus, I hope. Starting this weekend, you can look for the zodiacal light in the western sky during evening twilight. And it's a big diffuse cone of light stretching up and to the left from the western horizon. Very attractive. 20th of February, last quarter moon. On the 21st of February, I'm not sure this is even going to be observable, but the moon is going to occult Tau Scorpii just a few minutes before sunrise. So with a telescope, you may be able to pull the star out of bright twilight and watch the occultation. Something I will try. The 24th and 25th of February, we've got Saturn, Mercury, and Venus are all low in the western sky shortly after sunset. And on the 24th and 25th, Saturn and Mercury pass each other. So just 2 degrees between the two of them. Saturn 2.3 magnitudes fainter than Mercury. So it'll probably be maybe even rather difficult to see. Certainly you want to have binoculars available. New moon on the 27th. The 28th, I think is going to be really exciting. An extremely young crescent moon, less than 23 hours old, will be 3.6 degrees below Mercury. This will be very low in the western sky just after sunset, still probably in civil twilight, maybe the end of civil twilight. And if you can try for it, Saturn will be 2.2 degrees below the moon. And as a guideline, Venus at magnitude minus 4.8 will be 16 degrees above the group. So that will provide a really valuable guidepost to help you find the area. I always find that these things, when they're very low like this, it's hard to get the azimuth correct, and I usually forget to bring a compass. So here's the view of the 28th with, you can see the moon in between Mercury and Saturn, Venus well up above them. The following evening, the moon will be up beside Mercury. So also another very attractive sight. The benefit of seeing it on the 28th is that the moon is still less than a day old, which is, I think, one of the challenge observations for the Isabel Williamson lunar certificate. And of course, the lower it is, the more enhanced the earth shine will be. So in early March, going out to our next meeting, 1st of March, okay, that's that same Venus, Mercury, Moon, Saturn event. 4th of March, just after supper time, 2 moon shadows will be visible on Jupiter. First quarter moon on the 6th. The 8th of March, Mercury will be at its greatest elongation east. This is its best evening apparition of the year. So if you want to see it, it's a good time to do so. 9th of March, daylight saving time begins. And we all hate that. The 11th of March, again, double moon shadows on Jupiter. This is later in the evening. And then as Alan pointed out, on the 14th of March, this is just a couple of, in fact, just one day after our next meeting, total lunar eclipse. So we all want to get prepared for that. T Corona Borealis is getting higher in the morning sky, and in fact now transits before morning twilight. And as of this morning at 6 o'clock, it was still about 10th magnitude. The major planets, Mercury is setting about, so this is sort of mid-month, setting in bright evening twilight, getting higher towards the end of the month. Saturn is getting lower and lower, and I think next month it's actually in conjunction with the sun. Neptune at mag 7.9 is setting mid-evening, so it's already pretty low to be seen. Venus, the spectacular evening object at mag minus 4.9, is still well up in the southwest after sunset. Uranus is just a little past the meridian after sunset and sets an hour or two after midnight. So it's available most of the evening. Jupiter, the big thing for the nighttime, basically appears to be almost overhead in evening twilight and sets after midnight. And Mars, following along, transits in the mid-evening and sets before morning twilight. Small bodies on the 12th, that was today, 29 Amphitrite is at opposition. And on the 12th of March, 8 Flora will be at opposition. And in the occultation world, we have 4 coming up in the next little while. On the 20th of February, that's the 21st Universal Time, Bill Merlin occults an 8.5 magnitude star for up to 2.5 seconds. So that's an 8.8 magnitude drop, essentially to invisibility if you're in the path. And that's available for Bell Rock, Sydenham, Perth Road Village, Battersea, and anybody who happens to live in those lucky areas. On the 23rd, again, also, this is the evening of the 22nd, Tsiolkovskaya, 16.4 magnitude, asteroid occults an 8.4 magnitude star. And that one's good for Sydenham again, Battersea again, and Yarker.
Winner, winner.
Yeah, chicken dinner. 26th of February, 1662, Hoffman. This one you can see from the blue line is are the edges of the predicted path. The red lines are the 1 sigma error limits. So you can see this one seems to be a little less well predicted than some of the others. I think this one is good for our far eastern observers like Morrisburg and possibly Winchester. I can't remember. And then the last one on the 10th of March, I don't even know how you pronounce this, Terovimi, cuts down again, just catching the northeast end of Kingston. I think Yarker Bellrock is just on the edge of the 1 sigma error limits. Again, on this one, you can see the 1 sigma error lines are just barely outside the predicted path. So this is obviously one that is well predicted, presumably. Oh, and Davidson's Beach. Anybody happen to be in Davidson's Beach?
Yes, Mark.
Yes. So that's all I have for the next 30 days or so. Do we have any questions?
Anyone got any questions? No, being none.
Thank you.
Thank you, Rick. And next we have John Hurley with a National Council report.
Hello, everyone. This past Sunday, the National Council of the Royal Astronomical Society had its first meeting of the new year, and we started off with some good news. The projected budget for this past year is going to be should be under 14 grand. So we've come a long way in the last 2 years to getting our budget back into control. So the society is hoping it will get back into some of its promotional and educational materials that they were doing in the past and some other things along that line. So that was very positive news. They've also set a date for the GA this year. It's the weekend of April 26th, 27th. And yes, that is near a new moon, but all the dates near full moon are out of the question for various reasons. So, but it is a totally online event this year, so it should be good anyways. And maybe we can have some remote observing from various observatories across the society on some of those evenings. There will also be, let me just share my screen briefly here, some maintenance going on for the society's website coming up this spring. So the main page that we've had for the public face of the society is going to be updated. It's been using Drupal 7, which is coming to the end of its useful life. So they're going to be updating and changing our web servers to a different company. And during the changeover, it is going to be going over a period of a few weeks. A lot of the parts that would happen here, such as publications, issues of the journal and the bulletin, will be switching to the secure site. that will be so you'll be logging in through here and getting your stuff that way. It's so there might be problems accessing this, but everything that the membership should need will be migrated over, and then eventually this will all settle down. So if there is some problems getting through here to the eStore or something, go to your secure site login and access the society. There will be updates posted in the RASC bulletin that they email out once a month. So stay tuned, and hopefully this goes off without too much of a problem. And that's about it for the highlights.
Thanks,
Unless there's
John.
any questions.
Any questions, anyone?
Thank you.
Thanks very much, John. Good to hear about those numbers. Bruce Elliott, are you there? And would you like to speak on Science Fair, Science Rendezvous?
Yes, yeah, I'm here.
Great.
And yeah, so just I really enjoyed the meeting tonight. And I'm excited to be able to tell you that our science fair will be it's our next major outreach event, which will be on March the 20th. That's when the final showing of the projects to the public happens. And so there is some preparation ahead of time, though. So we, as I think most of the people online right now know, that we have the Leo Enright Award, which is a $150 award plus a beginner's observing guide, which we give out to. It can go out to any. It's a single award. It would go out to any project from very junior up to very senior in the fair. Just to give you a bit of an idea of the kind of projects, over the last 3 or 4 years, we've had two very exciting rocket projects where the person makes their own rocket and does some significant research and calculations to try to maximize the power of the rocket. We've had one presentation on Martian soil, which was based on a sort of artificial Martian soil provided by NASA for public and high school outreach. Then we've had, and there were actually, as I say, there were actually a couple of those. There was a very exciting project on gravitational waves, where somebody, a high school student, generated waves through a medium of jelly, of jello, and walked through how you would measure it, and what the meaning of it was, and that kind of thing. So it's really a very exciting experience to see these young people presenting and being very proud of what they've done. And so for our deciding how we're going to present the Leo Enright Award, we need to the process is, first of all, it would be nice to have a couple of people. Last year we had Elena and Graham Hay, and they both signed up as judges with the that can be done online, and then so just about in the last 10 days before the final presentations of the projects, they are shown online, and this is actually open to the public. People can go in and look at the projects. There's obviously security and names and schools and that sort of thing are not mentioned. So what we have found in the last couple of years when they've been running this was that it was very useful ahead of time for us to look at the projects, review them, and decide how we would like to rank them. And then at least one of us would go to the actual in-person show at the end of this year. It's going to be on March the 20th, and actually talk to the people that we feel would be potentially deserving of an award. So what I would suggest is that, well, I'm definitely interested in following through with that, and so Elena, I believe you've mentioned that you'd be interested again this year. Is that correct? Is she still here?
Yes.
Yeah.
Yes,
Okay.
Bruce.
Yeah.
Thank you.
Yeah. Okay. Yeah. Thank you so much, Elena. And I did invite Graham again as well. I haven't heard back from him, but it would, if anyone else is interested in participating in this, please do get in touch with me, and we can discuss how to move forward and get you signed up.
All right. Thanks, Bruce.
So that's the first thing I wanted to say. The second was related to the Science Rendezvous. And this year, the Science Rendezvous will be on the 10th of May, Saturday. And it's held, every year it's been held at the Slush Puppies place. And so there's not a huge amount more to say right now about it, except that we have sent in a confirmation that we will present and have a booth, and it still would be if anyone's interested in being involved in that, other than the people that have already signed, been involved in previous years, then please let us know. There is one more meeting they have before of coordinators that they have before the end of before the actual event, and that's on May the 1st at 4:30 at 4 o'clock in the afternoon on May the 1st, and that's just 9 days before the event. And that meeting will be held at the Slush Puppy place. So I'll definitely go to that meeting, and anyone else would be interested in coming to that or actually participating in the actual event. So does anyone have any questions they want to ask about that?
So Bruce, I think we can follow up on the chat list in that, and we can work together to find volunteers from the center.
Yeah, okay, that's great, thanks. And I will, I can make a brief summary of what I've just said right now.
That'd be great.
Yeah. yeah, I'm looking forward to it, and I think it's been a very exciting event, and several of the people in our group have, I think, would say exactly the same thing. They enjoyed it very much.
Great.
Thank you.
Thanks.
Mhm.
Okay, so just to wrap up, on Wednesdays, we have at the RASC-Kingston Centre, we have Zoom socials, which came out of basically after COVID. We decided, well, this is a great way to stay in touch. So we get together on Wednesday nights and just an opportunity to chat and discuss what we're up to. And if you're a member of the center, you're welcome to join. An email with the Zoom invitation is posted to the center's email list. Tomorrow, on February the 13th at 7 p.m., we will be having our third in our series of astrophotography workshops. This is a tutorial session via Zoom. We will be focusing on target selection, framing, and planning, as well as auto guiding and image calibration. The RASC-Kingston Centre has a monthly newsletter. Our editor is with us tonight, Roger Hill, and regulars can be found on the RASC-Kingston Centre website at kingston.rasc.ca. We have a Facebook group on Facebook. It's the Kingston Centre on Facebook, and it's also the Kingston Centre on YouTube. And on YouTube, a recording of this meeting will be posted in a few days. If you're not a member of the RASC-Kingston Centre, you are invited to join us. Welcome to join us. Just go to rasc.ca and click on Join Now. And then you give them the list of centers to choose that you want to join. So our next Zoom social is Wednesday, February 19th at 7 o'clock. And our next monthly meeting in person will be on March the 12th. And as I said earlier, our winter meetings were Zoom only, and now we go back to in person in March. That's held at the Ellis Hall, room 225 at Queen's University in Kingston. And thanks again to Alan for his great presentation tonight. Thanks to everyone that participated. And thank you to all of you for coming out or joining us on Zoom. Susan, did you have a question?
Yeah, I just wanted to make a brief comment about the social hours that we run on the Wednesdays. The general invitation goes to the center chat list. So if you're not on that chat and you would like to be added to the list of people who get the link for the Zoom for the Wednesdays, send a note to Kingston at rasc.ca and I will retrieve your request there and I'll add your email to a separate group of people who get the notice of for the Wednesday nights. Because it's not a general membership blast.
Right. So that's the end of the meeting. I will keep the Zoom open for as long as anybody wants to hang around and chit chat. But the formal part of the meeting is now concluded. And thanks for coming out.
Mm-hmm.
Thanks, Alan.
Thanks, everybody.